welcome to my channel. So here is the example of SIC simple. Okay, so the first step we have to know is whether the given example is of SIC simple or SIC XC. Okay, so in this case, is in the upward section we can see here is no plus sign. That means this is the case of SIC simple. Okay, so suppose if we have here, suppose if we have plus sign in this LD or in any of this section, then it would have been the example of SIC XC. Okay, so in this way you can identify whether the given example is SIC or SIC XC. So now we have to fill up this LOC and object code. So this is the example of SIC machine, okay, or SIC program. So in the SIC we have opcode, and here is X and operand. Okay, so this opcode is of 8-bit, X is of 1-bit, and this is operand is of 15-bit. Okay, and total is 24-bit. So if we have X is equal to J, then it is the direct addressing mode, that is target address is equal to address. Okay, so we will perform it later. So and if X is equal to 1, then it is indexed addressing mode. Okay, so then target is address means address plus X. Okay, we'll solve it later. So by applying this we can use, so here we have to fill up this table. Now to fill up this table, at first we have here is in the LOC section we have to fill up this LOC section. Okay, so here in the start section we have start section, write as it is. This is the absolute address. Okay, that is 3000. So means write in the LOC section 3000. Either left this section empty or you can write 3000. Okay, so first of all we have to start from this start. So that is 3000. So and here is so the best option to solve this is, suppose if we have here no sign, plus is equal to no sign, then increase by 3 section. Okay, that is 3 byte. If we add this, here is we have to write out the address of this LDS. Okay, so LDM is 3003, and again if we have multiplication, that is so no sign 3006, again add 3009, again here we have start, so we have to write out this address 3000C, and again if the address of this start, right, if we add 3 to it, see 3000 F. Okay, and again you have to always remember that if in the reserve, if we have this reserve section, suppose if we have this reserve section, then we have to multiply by 3. Okay, the term we have in this expression term. Okay, expression term, that is if we have suppose here 12 in the expression term, then we have to multiply by this 12 into 3. So if we multiply this section, we obtain 36. This is the term we obtain in decimal term, but we have to write all this in hexadecimal term. Okay, so if we change this 36 into hexadecimal, it will have been become 24. Then we will have add this 3000 F plus 24. Okay, so we will have written 3033, but here we have only 1. So if we add 3000 F plus 3, then it becomes 3012. Again we have same case, then add 3, then it becomes 3015. And always remember, in the odd case we will not multiply like this. Okay, always if in this odd section, if you even obtain 100, 200, just add by plus 3. Okay, just add by plus 3 in this below section. So that means it becomes 3015 plus 3 is equal to 3018. Okay, so it becomes 3018, and so in same case, then 3018 plus 3 3001B, and again in this case same 3001 B plus 3 means 3001E. Okay, so okay, now we have to write object code by looking this term and looking at this LOC term. Okay, so we can solve this. So in the start section, as here is no address saved or no object code saved, so we can write this as simply dash, and in the this section we can simply write this. So, and this only is used to reserve the word, okay? So byte of memory. So here in this section write simply write dash. So we can write like this dash, okay? Now we have to fill up this section, okay, object code. Now in this section we have to write, so here we have LDA, and in the mnemonic we have LDA means 0 0, okay? So write 0 0, and as earlier we have discussed that if we have x is equal to 0, this means direct address is equal to target address is equal to address only. So that means, so the target address of this is, we have to look up this target address of this expression section, okay? So the target address of this C is, here we have 3000F. So we have to write 3000F. And in the 9 multiplication, here we have to look up this small multiplication section. So small means 20, and the target address of this 9 is 3015. Okay? So again, the div is 24, and the target address of 5 is 3018. Again, we have to the mnemonic opcode of this is 8 is 18. So 18, and target address of this 32 is 3001B. Sorry, this section here is, it is STA, okay? So this is only STA term. So the STA is 0C, and target address of 5 is 3018. Okay, so the main point to remember here is that in the SIC simple, you just have to write out the opcode of this mnemonic, that is here looking in the opcode section, okay? So LDM is C00, and after this 2-bit, then after this here we have to write the expression term target address, okay? So we have written like this. So here dash, and here in the word 0 0 0 and 3 4 0 9. So 9, okay? And again in the 5 we can write like this as 0 0 0 0 and 5. And in the 32 section, as I have said earlier, we have to represent all the value in terms of hexadecimal, okay? So this 32 is what? Decimal. So we have to convert this into hexadecimal. That means it becomes 20. 0 0 0 0 20. In this earlier section we don't have any value, so we have written this as like this, okay? So this is the final table value we have obtained. Now we have to write the object program, okay? So for this we have to write head record, okay? So in the head record, after head record we have to write program name, then after we have to write the starting address of object program, okay? Then length of object program in bytes, okay? So that means here we have to write by taking this as consideration, okay? So we can write like this as head, then this is the symbol to concatenate both terms. So head, and after that write head, then program name is test, okay? So this is the program name test, then starting address is 3000. So 3000. So is here it is of the 3 bytes. So we have to write this total of length of 6, okay? 6 bit. So then we have to write the length. So length means this last term minus this first term, okay? So 10 0 0 0 1 E, okay? Now 0 0 1 E. Now in the text record, address of the object code. So this is the starting address of object code, okay? So starting address of this object code is 3000 again. 0 0 3. So totally 6 bits, that is 3 bytes. Now after that write the length of object code in record, that is we have to count out this all the term, okay? So if we count out this term, so in the text record we have to first write the text, then starting address of this Now we have to write the length of object code. That is, for the length of object code, here we have to count from this to up to 69. That is up to from the length to, that is so I can write the format of this text code is, that is, in the column 1 it is text, in the column 2 to 7 the length is, and it is length, starting address this, and in the column 8 to 9 we have to write the length of object code, okay, and in the column 10 to 69 we have to write the object code represented in hexadecimal, okay. So that means, so we have to count up to the 60, okay. So we have to write obtain this term less than 60, that is, so count from this, here is 1 2 3 4 5 6, so total 6 3 6 6 6 6, that is 1 2 3 4 5 5 6 7 8. So if we multiply 8 into 6, so this 48 term is less than 60, okay. So if we have obtained, suppose if we have obtained 60 up to this, then we have to make another new text record, okay. So we have obtained the 48, now divide by 48 by 2, okay, so 24. So if we obtain, so we have to convert this term into hexadecimal, okay. So in the hexadecimal it becomes 18, okay. So we can write as, here we have set column 8 to 9 length of 18, okay, 18. Now up to the 69 term, so take column 10 to 69 we have to write down the object code, okay. So this object code, so we have to write from this beginning, so 00300f and up to the last term, that is, here we have this term, okay, 00020, okay. So 0020. Now in the end record again, so in the end record we have to write the address of first executable, that is, we have to write the first address, okay. So that is 003. So this is the final solution for object program, and this is the solution we have obtained for object code and LOC, okay.